A car is traveling at 70 kilometers per hour. When the traffic light turns yellow, the car accelerates at 1.5 meters per second squared for 3 seconds before it turns red. How close does the car have to be to make it through the light? So we are going to start with our knowns and unknowns. So for knowns, we know it has a velocity of 70 kilometers per hour, has a time of 3 seconds, and an acceleration of 1.5 meters per second squared. And in this one, we are trying to find x. So first, we are going to change 70 kilometers per hour into into meters per second. So we're going to use dimensional analysis to do that. So you have 70 kilometers per 1 hour. 1 hour equals 60 minutes. 1 minute equals 60 seconds. So we have seconds there. We can cross out the minutes and we can cross out the hours. And then 1 kilometer equals 1,000 meters. Cross out the kilometers. And when you multiply that all out, you get 19.4 meters per second. So that's what our velocity is. So now we can use the equation, which is for constant acceleration, x equals velocity initial times time plus 1/2 times acceleration times time squared. So now we just have to plug in all our numbers. So it's going to be x equals 19.4 meters per second times 3 seconds plus 1/2 times 1.5 meters per second squared times 3 seconds squared. And when you do that all out, you get the displacement, which equals 64.95 meters. And this is how you solve for the distance the car needs to be from the stoplight when it accelerates at a constant acceleration to get through the light. Now, we have our second problem. A second car is going 55 kilometers per hour, traveling perpendicular to the first car. It crosses the stop line, which is 15 meters from the center of the intersection. At a constant velocity, how close do the two cars come? So for this one in our diagram, we're going to have another car that's going perpendicular to the first one. And we are first going to start by doing our knowns and unknowns. So our knowns and our unknowns. We are going to call this car A and this car B. So we know the velocity of car A is 19.4 meters per second, and we know the velocity of car B is 55 kilometers per hour, and we know the distance for car B is 15 meters, which is from the stop line to the middle of the intersection. And then we don't know the distance for car A or the time. First, we are going to start by changing the 55 kilometers per hour into meters per second like we did in the last problem. So it's going to be 55 kilometers over 1 hour. 1 hour equals 60 minutes. 1 minute equals 60 seconds. So we have our seconds. And then 1 kilometer equals 1,000 meters. So we have meters per second, and that comes out to 15.28 meters per second. Now we are going to use our equation of constant velocity, which is x final equals x initial plus velocity times time. So our x final is going to be 15, which is the middle of the intersection. And our x initial is 0, because you're starting at the stop line, plus a velocity of 15.28 meters per second times t, because we don't know how many seconds it takes. So once you solve that all out, which the 0 doesn't mean anything, so you just divide by 15.28 meters per second on both sides. You get t is equal to 0.98 seconds. So that's how long how far apart they are. Now we're going to solve for x of a, the distance of a, so how far apart they are in distance. So we're going to use the same equation, only we're going to plug in different stuff. So it's going to be x of a equals x of I plus velocity times time. So it's going to be x of a equals 0 plus 19.4, because that's the velocity for car A, times 0.98, because that's the time. So you're going to get x of A equals 19.05 meters. And that is the distance the two cars come.